This is David Voss, CCIE 11372, and this is a demo of my training for EIGRP. EIGRP is a robust routing protocol that offers quite a few features. And we're going to tackle EIGRP through three angles here. First, we're going to do a lesson on EIGRP just to cover some of the basic features of this routing protocol. Next, we'll go into a lab and simply enable EIGRP on a router. I'll show you how to do that. And finally, you'll have a quiz you can take where you can take a test on some of the features and programming you learned today. So let's jump in. EIGRP features. The key to EIGRP is that it has fast convergence. It converges as fast as any other routing protocol. This is important. Convergence is important. And for an example, if there's a big news event in Europe, and all the news agencies eventually want to pick this up, but initially, the BBC gets the news event. And when that happens, the whole world does not know about this big news event. The news is not converged throughout the news agencies. All of the people in the world don't know. But when the New York Times pick it up and the Australian picks it up, the world knows about this important information. That's convergence. And that's important because when a new subnet is advertised on a network or brought live on a network, other routers need to know about it. Otherwise, no one's going to know how to get to it. So convergence and the speed of it is important. The other routers eventually learn about this subnet from a routing protocol, EIGRP. They need to know it quickly, otherwise there's going to be black holes or routing loops. Another feature of EIGRP is partial updates. It doesn't have to send its full routing table to its neighbors. Just when there's a new subnet, it'll send that partial update. That's important because it saves on CPU and network resources. It has a network discovery mechanism. Checks if neighbors are up and down using hello packets. And it has other features that you certainly most likely know about at least. VLSMs, it has route summarization, and it scales really well. You can create a very large EIGRP network. So let's dig in. Let's go ahead and enable EIGRP on a router. And let's go ahead and take a look at what subnet we want to advertise. And we see 172.31.16.0/24 here. So let's enable EIGRP. It's as simple as typing in router EIGRP and then an autonomous system number. So you need to pick an autonomous system number. And for this sake, we'll do 10. And let's go ahead and advertise that subnet on Ethernet 00. How we do that, by advertising an EIGRP, you type network and then the subnet. And then instead of the subnet mask, you actually inverse. EIGRP uses wildcard bits, so you do the inverse of the subnet. And that's pretty straightforward. Once you've done that, you've actually enabled that network to be advertised in the EIGRP routing protocol. So let's take a look at how it looks in the running config. Basically, in 2 lines of coding, you can see that we've enabled EIGRP via router EIGRP10, and then we have also enabled the advertising of that Ethernet interface, the subnet that's on that Ethernet interface, into the routing protocol itself. So that's pretty straightforward. Now, EIGRP has other features for troubleshooting, and a good example is when we do show IP EIGRP. You can check the status of EIGRP interfaces, check the status of your neighbors, topology tables, and traffic. This is all information we can cover in future training, but there are a wide array of commands you can run on EIGRP to make sure it's running perfectly. So I tell you what, let's make sure that you've learned what you're supposed to learn today. Let's jump on in and have you take that quiz that's been provided with this and see how you do.